Assalamu alaikum, this is 191017. Yes, Zahid. This is part 1 of lab number 5. In part 1 of lab number 5, we are going to test these 4 samples of arithmetic operation, which are multiply, divide and minus, and the fifth one is modulus. Now, what we are going to do is, we are going to assign two inputs, a is equal to 12 and b is equal to 3, and apply these initial 4 arithmetic problems, and on the fifth one we'll use this modulo to check the remainder. Now, coming towards the code, I've already compiled it so that it does not waste time. So here we have initialized our module, declaring all the inputs and the outputs. Here we have declared our 4-bit inputs, which are A and B, 8-bit inputs, which are C, D, E, F and G. Then we are assigning outputs to all our, we are assigning the values to all our outputs here, C, D, E, F, G. First one has multiply, then divide, plus and minus, and the last one, this line here, it's quite new. 1 colon B1 means simple 1-bit 1, and A is 12, its value is 12 right here, as we have declared it. We'll declare it in the RWF university function. So 12 plus 1 becomes 13, and its modulus with respect to 3, b is equal to 3, b is equal to 3 would become 13 modulo 3, which would become 1. Now we'll quickly jump to running of this. First of all, going to the RTL view. Now this here is the RTL view. What we are doing is we are just simply multiplying, dividing and adding and subtracting. Okay, now coming to its university VWF file, we'll just simply go here, then university program, okay, and go to node finder, list in all, okay, and okay. So here we have all of these numbers. Now what we are going to do is basically assign these the value. Now A equals 12, I'm just changing it to decimal so that it's easier to understand. So its value is 12, its value is 12, we don't want any increment, and okay, its value is 12. Now the second number, its value as an unsigned decimal, I'm giving it just to simplify the whole equation, 0. Okay, now we have our first input as 12, second input as 3. We will set the rest also to unsigned decimal so that we can clearly see from the results what's going on. Now just a second, let me change all of these to unsigned decimals. Now we will simply compile it. Yes, sure, save, stop. Now what we will get after this is the wave type result, but since I have chose unsigned, so we will simply get our answers. Now here we can see 12 multiplied by 3 equals 36, 12 divided by 3 equals 4, 12 plus 3 equals 15, 12 minus 3 equals 9, and in program we wrote 12 plus 1 modulo of 3, which means 13 modulo of 3. So it will reduce to 1, since 1 is the remainder when we divide 12 by 3. So this was all for the practical implementation of arithmetical operations. That's all for this video. In the next video we will implement the exercise.